In this video, we're going to talk about what controls temperature and why it varies from location to location. When we're discussing temperature control, this is just any factor that can cause our temperature to be different from one location to another or over different periods of time. And the main thing that controls what the temperature of a location will be is the latitude of that location. How close or how far are we to the equator? If we're closer to the equator in those low latitudes, it's going to be a higher temperature than if we're in the higher latitudes around our poles, where it's going to be a lot colder. And related to our latitude is going to be the amount of solar radiation we receive. And solar radiation is the amount of light and heat that we're getting from the sun. When we're at the equator, the reason why it's warmer is because we're getting more intense solar radiation. We're getting more heat and light from the sun, making it warmer there. But when we're at our poles, the reason why it's cold is because it's getting very little solar radiation. So we see that latitude and solar radiation go hand in hand with each other. But we also see that land and water heat up and cool down very differently from one another. And this is called differential heating, just different ways that they heat up and cool down. We see that water takes a lot longer time to heat up than land does. Overall, the land is also going to be able to get hotter than the water does. So think about if you're walking around barefoot during the day. I keep making the really poor habit of checking my mail barefoot around 2 p.m. And to check my mail, I have to walk outside on asphalt. So when I'm walking on that asphalt barefoot, it's going to heat up a lot. It's going to be really hot on my foot when I'm checking the mail. But if I were at the beach that day and I was walking around in the water, because water heats up less, it's not going to be as hot on my foot as it would be if I was barefoot in the water versus barefoot on asphalt. And that's because land not only heats up faster than water, it cools off faster than water as well. So we're going to see major differences in coastal areas versus inland areas like Kansas. The reason why we see land and water heating up and cooling down differently is due to differences in their specific heat. And the specific heat is just the amount of energy that's needed to raise the temperature of something 1 degree Celsius. And we see that water has a higher specific heat than land. So this just means that it takes a lot more energy and time to heat up and cool off water than it is to heat up or cool off land. So in this image, this is a satellite image of heat around California and the Pacific Ocean. Here we can see major cities like LA and San Francisco, and all of the land in California is showing up as a bright red. Looking here, it's telling us that this is the highest temperature that we can possibly get. The land of California is incredibly hot. But if we look just off the coast at the Pacific Ocean, this water is significantly colder. We're going to see that the reason why is all due to specific heat. The land of California is hotter because water takes more energy and time to heat up. So we see that it's going to remain cooler while the land heats up warmer. If we're looking at two different areas, one is on a coastal area and one is near the center of a continent, we're going to see that the water is going to control the temperature in that area. If we look at this graph, we're seeing temperature in Vancouver and Winnipeg, 2 cities in Canada. Vancouver is found along the coast. Winnipeg is found in the middle of the country. When we look at how its temperature changes throughout the year, you'll notice that in Vancouver, the temperature doesn't change a whole lot. The coldest is about 2 degrees, the warmest is about 17 degrees. That's because it's along a coast. It's surrounded by water, which is going to help limit temperature change. Because again, it takes a long time and a lot of energy for water to heat up or cool down. Winnipeg, on the other hand, we're going to see this huge difference between negative 18 degrees in winter and 20 degrees in the summer. That's because Winnipeg is found in the middle of the continent. It doesn't have a lot of water nearby to control its temperature, so we see major swings, really cold winters, really hot summers. Whereas that more marine-based Vancouver, the water is going to help balance out the temperature year-round. But there are some other things that affect our temperature as well, like our altitude. We're going to see that in mountainous areas, it's going to be a cooler temperature than lower elevations due to that environmental lapse rate. We also need to look at the difference between like our cloud cover. If we live in a place like Seattle that's known for cloudiness and lots of rain, it's going to be cooler than nearby locations. And a lot of this is going to deal with the albedo, or the color of the surface. When we have lots of light-colored materials near the surface, like clouds that are white, they're going to reflect more sunlight back into space, help keeping that area cool. But if we have a place like a city with lots of dark-colored asphalt, it's going to absorb that solar radiation from the sun, heating it up more. These two images just build on our last slide. When we're talking about winds, we can look at New York City and Eureka, California. Because Eureka is right along the coast where there's water to help stabilize the temperature, as the winds blow through, they help control the temperature in Eureka, California. It doesn't change a whole lot over the year. But as our winds are moving over our entire continent, making their way to New York City, by the time they get here, you'll notice that New York has really warm summers as well as really extreme winters. So we have a bigger range in annual temperature due to the different types of winds and whether they're holding moisture or not. But another thing that influences our temperature is elevation. And here we're looking at two cities in Ecuador. One is right along the coast. You're going to see that it remains relatively warmer because it's lower in elevation than our city that is in our mountainous region. At a higher elevation, it's just going to be significantly cooler in temperature, again due to that environmental lapse rate.